everyone, this is Pavithra, Assistant Professor, Department of ECE. Again I came with the same topic like transmission line equation, general equation or general solution. The main aim of this transmission line equation is to find the voltage and the current. Okay, that is the main aim of this. We know very well what are the parameters of the transmission line. It is very important. It is a resistor, inductance, capacitance and the conductance. These are the parameters of this transmission line. Okay, in the last video we have discussed the how to write it, the shunt series impedance and the shunt admittance. So series impedance, how we have written Z is equal to, impedance means Z, okay, Z is equal to R plus J omega L. For the shunt admittance we have written Y is equal to G plus J omega C. This is L and this is C. Okay. If I want for the particular small session, I have to multiply this thing, right? R plus J omega L into dx, because we have multiplied that. After that here G plus J omega C into dx. We have multiplied the thing. Next, what we are going to do again, in this diagram I have modified it. One is the input. What I am calling as, this is a sending end and this is a receiving end, right? Okay. So in the sending end I have taken the voltage V plus dV and the current I have taken I plus di, and here I have taken the current is I and the voltage is I. So now what we are going to do is the voltage drop across the series impedance of the T session. That means I am going to take the potential difference between the sending and the receiving end. That means sending and the receiving end. So how I am taking as V plus dV. This is a sending end, okay, and that is a receiving end. So this is for voltage. Okay, this is for voltage. So I into R. What is the Ohm's law? I into R. So here R is nothing but the impedance. So that we have written in the R plus J omega L. Okay, J omega L. Now what happened? This dV will get cancelled. So dV is equal to I into R plus J omega L into dx. Okay, now I am going to take this dx here. So dV is equal to dx is equal to I into R plus J omega L. Okay, then finally where we know very well, already have explained here that the R plus J omega L is nothing but the Ez. So R plus J omega L is nothing but the Ez. So I am going to replace here. So dV by dx is equal to I into Z. That Z is nothing but R plus J omega L. Okay, this is our first equation. So dV by dx is equal to I into Z. So this is our first equation. So this is the first equation we have derived from this transmission line. Again, now we have taken, already I have said here in the main thing is the voltage and the current is the main thing. So what I have subtracted the receiving end and the sending and the receiving end. Again I am going to take the current, the voltage, the current difference between both the things. What is the current difference? I plus di, and the receiving end there is a I. So minus I is equal to, I am going to take it as V divided by G plus J omega C into dx. Okay. So here we have taken current into voltage, but here there is a current. So I have dividing voltage divided by G plus J omega C. Okay. Then so this I get cancelled like before, and di is equal to V divided by G plus J omega C into dx. Again I am going to take this dx here. So di divided by dx is equal to V into G plus J omega C. So finally G plus J omega C is nothing but di by dx, that is equal to V into y. So this is the second equation. Okay, this is a second equation, and then so still now what we have discussed is, I am going to recall it for, because I am going to erase this one. So this one is we are differentiating and we are finding dV by dx is equal to I and R plus J omega L. Again here I have replaced R is equal to that, and finally I got dV by dx. Again I have to take how I take the voltage difference. Same thing I have to take it for the current also. So I have subtracted it and I have written, and then so 1 by R is equal to 1 by Z. Okay, that's why the term is coming in down, and then I can be replaced here as a Y. So y term is g plus j omega c. So dx is equal to v into y. Okay, so in the next video we will see how to differentiate. We have to differentiate this one, and we have to put it in the propagation constant. Okay, in this thing we have three parameter constant terms. One is alpha, gamma and beta. Now we are going to see about the gamma. Gamma is nothing but the propagation constant. Simply propagation constant gamma is equal to root of zy. Why we are deriving this term means because we need to find the propagation constant gamma, impedance into admittance. So if we want to multiply this the term to get the gamma term. After that we have to find the arbitrary equation like a b c d, and then we have to find a b c d, and we have to substitute, and finally we can get the equation like v is equal to I is equal to. Okay, so in the next video we can discuss how to differentiate this term. Thank you for watching.